right. Hey, everybody. Welcome to NDC Sydney. My name's Mike. I have the distinct privilege of trying to follow Scott Hanselman, and I promise that I probably won't be anywhere near as entertaining as that guy. This session is called A Picture is Worth 1,000 Lines of Code. It's about visualizing software systems, about stepping back from your code and actually getting an overall picture of what your system is doing and how it works. I'm going to start with a bit of a personal story from my own history, and then we'll look at a technique for designing and visualizing software architecture called C4. It's pioneered by a guy called Simon Brown. We'll look at a tool which is used to automate C4 architecture documentation and visualization. And then we'll look at messaging systems and how we can leverage the audit trail data that you can collect from those messaging systems to visualize those systems in a bunch of different ways as well to get a feel for how those are working. So, like I said, my name's Mike Minutillo. I live in Perth, Western Australia, where I work in my home office for a company called Particular Software. We make the reliable messaging platform in Service Bus, which is the infrastructure behind the NDC Sydney 2016 Twitter leaderboard. I always screw that up. Has everybody seen the Twitter leaderboard? All right, so if you tweet using the hashtag NDC Sydney throughout the conference, there's actually a leaderboard that's collecting and aggregating those tweets, and it puts your name on a board so you can see the top 10 people, that are tweeting, the top 10 people that are being retweeted, and so on. And we're collecting and aggregating that data, and you can see it on all main screens around the place. So before I get started, can I just get a show of hands? Who's actually heard of In-Service Bus? Lots of people. Awesome. Can you keep your hands up if you're currently using In-Service Bus? Very few people. So everybody's heard of it, but nobody's using it. It's okay. So when I was first interviewing with Particular, I had heard of In-Service Bus, but what I didn't realize was that they make this suite of other tools to go and support In-Service Bus systems. And when I first joined the company, I heard a rumor through the grapevine that I was going to be working on this one. It's called Service Control. Has anybody heard of Service Control? 2 guys and one of them works on it, which is awesome. This is going to be great for my talk, right? Because when I first heard about it, I didn't know what Service Control was. And now Particular is an open source company, so I did what I think a lot of the people in this room would have done. I went to GitHub, I found the source code, I cloned it locally, and I opened it up in Visual Studio and I hit F5. And it ran. And it ran as a console application and put out a bunch of log messages. And then I had absolutely no idea what to do from there. I didn't know what the system did. I didn't know how to make it do what it did. I didn't know even who would be using it normally. So I stopped it and I jumped into the code in Visual Studio and I went looking for clues. And the first clue that I found was, I found references to Owen and NancyFX. So maybe Service Control is a website of some description. Then I found references to In-Service Bus. That's not a big surprise. This is a tool designed to support In-Service Bus, so now it's a website that's doing messaging maybe. And then I found references to Caliburn Micro. So now it's a WPF desktop application website that's also doing some messaging. And then I found references to Raven DBs. Now it's talking to a database somewhere. I don't even know what's in that database or where that database is. I was completely and utterly confused. And after a few hours of digging through the source code, I still didn't have a really clear picture of what Service Control is and what it does. But I had to stop at that point because I had my first scheduled meeting with my onboarding buddy, Greg. He's over there. Hi, Greg. And I asked Greg about Service Control. I said, what is this thing? And he showed me this. And he talked me through it. He said, basically, when you have a system running on In-Service Bus, it's going to be sending these little packets of data backwards and forwards called messages. And when an endpoint gets a message and processes it, it's going to stick a copy of that message into a central location called an audit queue, and that's where Service Control is going to take over. Service Control is going to read that data out of the audit queue, do a little bit of processing on it, stick it in its own little internal database, and then make that information available to the other tools in the stack. Now, what Greg had managed to do with one picture and a few sentences, I'd not been able to do with hours of digging through the source code. Looking at the source code was showing me all the detail of what Service Control did, but it didn't help me to take a step back and see what Service Control was doing in the broader context. What I'd been trying to do was look at the shape of like a state forest by examining the individual leaves. And it was just not possible to do at that level. Now, after we'd had a bit of a chat and we'd been looking at this image, I had a question and I asked Greg, on this diagram, hey, there's this error queue thing underneath the audit queue. What does that mean? And he told me sometimes when a message is being processed, it runs into problems, and it can't be processed successfully. And instead of going to the audit queue, a copy goes into the error queue. And again, service control is going to pick up that information, stick it in its own internal database, and then make that data available to the other tools in the platform. In fact, you can even issue a request to service control, and it will push that message back into your system so that it can be processed again. I thought I understood what Greg meant, so I drew on the diagram. I said, like this? He said, yeah. So now, by communicating over this shared visual representation of what the system was doing, we were able to reach consensus and get our mental models in sync. Sometimes you really need to be able to step back and look at your code from a distance to figure out what it's doing. And unfortunately, a lot of the tools that we're used to, tools like Visual Studio, they're not really designed to help you do that. And a lot of the training and the skills that we have are not really designed to help us do that. And when I first started looking into how you could visualize software systems, I came across the work of this guy. His name is Simon Brown. He lives in Jersey, which is a small island in the middle of the English Channel. Presumably that's what New Jersey is named after. Does anybody know? I don't know. So Simon is an independent software consultant, and he's traveling around the world specializing in software architecture, helping teams get up to speed and deliver their software projects. And understanding the power of this visual communication, Simon would frequently stand at a whiteboard and ask the team members to draw their software. And what he found was, to varying levels, a lot of teams were not equipped to do so. They just didn't know how to do that. So some people would draw very complicated diagrams. Some people would draw diagrams at various different levels of abstraction. A lot of it didn't make sense, and it required somebody to stand there and walk you through that visual documentation. And it didn't really help. You really had to have worked on the code for some period of time and have a lot of context and a lot of history in order to be able to understand what was going on in the system. And so Simon started giving these people tips. Before asking them to draw their architecture, he'd give them one or two just pointers, like these are the sorts of things that I'd like to see. This is the kind of information that I'd like you to show me. And over time, that set of tips started to develop into a bit of a framework called C4. And you can learn C4 in about 10, 15 minutes. In fact, I'm going to go through it now. And by the time you get to the end of it, your entire team is going to be much more effective at communicating visually about your software. So let's have a look. C4 is primarily two things. The first thing is it's a set of common abstractions that are going to be used to describe your software architecture. So these are the building blocks that you're going to be able to take to describe your software system and how it's going to work. The second major aspect of C4 is a set of views. So once you have this model, you can then slice it in a number of different ways using these visualization techniques to be able to show the software at different levels. So let me show you an example. Jumping straight in at the very top, at some level, your domain is about software systems and users. You have people somewhere in your domain that are doing some job, and they're interfacing with software systems to help them to do that job. Now, here where I talk about software systems, I'm treating them like a black box. So no matter how complex it is internally, Facebook is a software system. Twitter is a software system. YouTube is a software system. Whatever project you're working on, it's just a black box at this level. So we've seen something very similar to this with service control. The context view is going to show your software system in context, surrounded by all the other users and software systems that it interfaces with. Let's have a look at the service control one. Starting with just dropping a box with the name of your system in the middle of a diagram and give it a 1 or 2 sentence description. This is going to help the first person who comes to your diagram, if they have no idea what service control is, that couple of sentences is really going to help them to figure out what they're looking at. Once we've got your system on the diagram, we need to add some more systems that are going to interface with your system in the middle. So here, because service control is interfacing with just some business system somewhere, it's just modeled as another box, just a business system that's performing some business function. And we put in a line to show that the business system is using service control. So that's what the direction of the arrow is. Now we want to talk about how that relationship is being managed. So how the business system is using service control. So just like we want to put a descriptive label in each one of the boxes, you want to put one on the lines as well. So here we can see the business system is sending some kind of data down to service control. On the previous diagram, we had another couple of software systems. Service Insight is querying data from Service Control. Service Pulse is querying data from Service Control as well. So this is just showing software systems. We don't have any users yet, so let's throw some users into the system. We've got developers using Service Insight, operations people using Service Pulse. These guys aren't talking directly to Service Control, but I still like to model them at this level anyway, because these are the people who are going to come screaming when I break something in Service Control. And there's one other class of user which is important at this level, and that's this guy, the system admin. She's going to be creating, starting, and stopping instances of Service Control. Now this is it. That's all the detail you're going to want at this level. There's no technology choices at this level. This doesn't say in-service bus anywhere. It doesn't say JSON or HTTP or RavenDB. This is how your non-technical stakeholders, the people in your business, this is how they think of your software system. So this is the kind of view that you want to be able to present to them. This is like a 30,000-foot view, as far above the code and the detail as you can possibly get. This is what your system looks like. Once you start to draw this and show it to non-technical stakeholders, an amazing thing happens. They actually have an opinion as to whether or not this is correct. Now, that was a massive surprise to me. I don't know about you guys. I spent years writing 100-page documents about software architecture, and you hand them over to the CTO and he pores over it and picks out all the nitpicky things that he doesn't like and then signs it. And you take it to the IT people and they read through and they pick out all the things they don't like and then they sign it. Whenever you give it to a non-technical person, they just sign it. They don't read it. This is a single diagram. It's going to fit on an A4 piece of paper. Maybe an A3 piece of paper once it gets more complicated. But the non-technical people are going to be able to look at this, read it, and internalize it very quickly. And they're going to have an opinion as to whether or not it's right. And you should listen to that opinion. Because those non-technical people have usually been around your IT infrastructure for some time, and they have some feel for what all the pieces are and how it all fits together. Frequently, if you're a contractor or a consultant, when you're coming into an environment, you have a lot less knowledge about the environment than the non-technical people do. So print out a copy of this and carry it with you, and at the end of every meeting, just sit down with non-technical people and get them to mark it up. Get them to draw on new arrows. Whenever people want to make a change to your environment, where they're adding new software systems or new users, get them to draw it on the diagram. Don't do it for them, get them to do it. Because it really helps you to get their mental model out of their brain and onto the page, and it helps you to reach consensus with them. So that's the very, very, very high level. We're so far above code that you can't even see technical details here. What's the next level down? Well, diving back into C4, the next abstraction down is the rather unfortunately overloaded term container, which was made very popular by Docker, but we won't hold that against them, because C4 was first, but Docker is far more popular at this point. Now here when we talk about a container in C4 terms, we're talking about a logical deployable unit. This is something that hosts either code or data. It could be a web application, it could be a Windows service, it could be a database, it could be a mobile app. And the container's view is going to decompose your software system into the containers that make it up. But it's still going to show everything else from the context. So all the other users and software systems that your system interfaces with are still going to be present around the edges of that diagram. Only now, instead of being connected to the black box that is your system, we've opened up your box into a white box, and we can see how those things are connected to the internal parts of your system. So back into the service control example. We can see we've got the black box of service control in the middle. So let's blow it up to something a bit bigger. We've still got all of our context around the edges, but I've taken the users away because on the slide there's actually not that much room. And here we've started to add some technical details. So the business system now is saying has to be built on top of in-service bus, and it's configured to use some kind of transport. And here, MSMQ, RabbitMQ, Azure Service Bus, however you're building the system. Notice that we haven't put all the technical detail on the document, so we haven't said how Service Insight and Service Pulse are built, because to service control, those things are irrelevant. But this is actually important to us. So in the previous diagram, we showed that the business system was sending just a single stream of data through to service control. But where does that data go? Well, once you actually open up the black box and you have a white box, you can start to see 3 different input streams coming through. We've got audits, errors, and basically everything else. And those things are going to be using that same transport. So that's why it's an important technical detail at this level. Behind those 3 channels, we've got a single Windows service that's going to be reading in that information. When that Windows service is wanting to store some information, it's going to stick it in a data store, which is going to be an embedded Raven 2.5 database. And we had our software system Service Insight and Service Pulse. They're going to be querying that Windows service using HTTP and getting back JSON responses. And then we've just got one other class of user, that's that system admin. They're not connected to anything at the moment. So when they want to manage instances of service control, it turns out they're actually using a completely separate desktop application written using Calibre Micro and WPF. That's where that technology choice comes in. Now, if the previous diagram was specifically for non-technical stakeholders, this is exactly the diagram you want to carry around to talk to technical stakeholders. It's exactly the same diagram, it's just got a little bit more information on it. And at this level, you want all of your technical choices, all of your technical details. You can put version numbers in here, put protocols in here. How are things communicating and how are they connected? This is the diagram you want to take to the CTO, because the CTO is going to want to know all those technical choices. When you're talking to the IT and infrastructure people, they're going to want to know all of the things that they're going to have to support in production and what they're going to look like. And when you're adding new developers to the team, this is the diagram that you show them, because it helps them to orient themselves throughout your solution in a way that just looking at a solution full of projects doesn't easily give you. This is actually showing you the relationships between the logical parts of your system and how they connect. So carrying on, diving even deeper, if we've decomposed our software systems into containers, the next step is to get a little bit closer and to take one of our containers and decompose it into something else. And the next abstraction in C4, unfortunately another overloaded term in software engineering, is the component. Now, component is a funny one. A component is a logical grouping of code or data that's got some interface to it that's performing some architecturally significant function. So if you've got a subsystem that's sending emails, no matter how many classes and things are involved, that's a component. If you've got something that's doing some calculation and other pieces of the system rely on that, no matter how many classes are involved internally in that thing, that's a component. So when you're showing the components view, you're actually taking one of your containers and opening it up and turning it into a white box again. But you're still going to have all the context from all the previous views. So you want all of the other containers in your system and how they're connected to these internals of this container. You want to know all of the software systems and users that are in that broader context and how they're connected to this container. Which components are they connected to internally? And when I first tried to do this for service control, I did it using some simple rules. I basically said, anything that's serving up an HTTP request, that's a component. So any of the Nancy modules, that's a component. Anything talking to the database, that's probably a component. Anything handling a message from an in-service bus standpoint, that's probably a component. And I started to put all this together into a diagram. And I got to this. And that's about when I stopped. Because even though this is showing a bunch of components and the relationships between them and how those things are connected to those external software systems and users and containers, we're starting to get too much detail in a single diagram. So now the diagram is actually losing its value because there's so much detail here that you just can't see the individual pieces. We're looking at leaves again when we really want to see the shape of trees. So what do? Well, you need to find some way to divide this diagram up. You need to find some mechanism by which you can pick out individual components that are important and show them all on the same diagram. So one way you can do this is to look at individual use cases. So here is a use case for service control. This is showing just those components which are related to audit ingestion, so pulling messages out of that audit queue, doing some processing on them, storing the data in a database. Down the bottom here, this is our external embedded RavenDB database. Pulling that data back out using an HTTP API, and then we've got our external software system down the bottom there that's calling into those things. Now imagine that you're a new developer on service control. Today is your first day. And you have a meeting with the team lead. And the team lead takes you into a room, and in front of a whiteboard, she draws the context view and talks you through it and tells you where service control fits into the broader architecture of the entire enterprise, where the pieces fit, and what they do. And then she scrubs out the service control box in the bigger and draws it again in a bigger manner. And then she starts drawing the individual containers internally and connecting them and showing you all the technology choices and all of the ways those things communicate. And then she pulls out this as a piece of paper and says, and this is the audit ingestion system. And for the next 2 weeks, I want you to be working with somebody in the audit ingestion system. How long did that conversation take? We've just been through it in about 16 minutes. And already I think most of you would feel fairly comfortable looking at the service control code, jumping around and looking now at the detail level. That's the power of doing this sort of visualization and viewing your software from standing right back. You can start from no knowledge and very rapidly get down to something very specific. So what's the next step? Well, imagine you've jumped out of a plane over your software. And down the bottom is the code in Visual Studio. And the first thing you see when you jump out of the plane is this context view. There's a black box, which is your system, and then a bunch of other black boxes that it's connected to. And then as you fall, as you start to get closer, now you can see the containers view. Now you can see the white box. You can actually see the details that are inside your software system, how those things are connected and how they relate, and how those things are connected to the other pieces of the enterprise. You fall a little bit further, and now you can see the individual components inside one of your containers. But it's a giant, complex mess. There's all these pieces flying around, and you can't make out any detail. But you fall a little bit further, and now you're closer. And now you can see just this particular area seems to have some shape and some understanding, and you figure out what's going on. And if you fall a little bit further, you're probably going to smack into the ground. But just before you do, you see the next level, which is classes. Anybody that's used to programming in an object-oriented language is already fairly aware of classes, right? We know we deal with classes all the time. At this level, the class view is just a UML class diagram, because this is the level just above the code. So your components and your components can be decomposed into the classes that make it up. And at this level, you're talking about inheritance, hierarchies, and collaborators, and that sort of thing. And I'm actually not going to show you a sample of a class view from service control because it's not that important. This level is entirely optional. And you would only ever construct a class view if you had something that was very complicated that you wanted to show to somebody. So if you had a complicated inheritance, hierarchy, or composition structure at the class level, then you would include a class view. So context, containers, components, and classes. 4 different views at different levels, slicing through your architecture. Those 4 views all start with the letter C, hence the name C4. Now, when I was looking at the service control diagram, that first one, something interesting occurred to me. I couldn't have drawn that diagram by looking at the code. The in-service bus pieces and the other applications in our product stack that appear on that diagram are not directly referenced in the code. No amount of looking through that code would have allowed me to generate the diagram. Which means you have to draw that kind of diagram by hand. You've got to do it manually. You don't really have a choice. But that's okay, because how often does the context view change? Or to ask the question another way, how often do you introduce new architecturally significant groupings of users or new software systems that you have to interface with into your project? Very rarely, right? And how long is it going to take you to update the diagram when it does change? 15 minutes? Half an hour? An hour if you're feeling really lazy and you just want to fill in your timesheet? You're talking about adding a box and a line to a diagram. Unless you've got a lot of boxes and a lot of lines, you're not going to have a complicated layout because you've probably got your system in the middle and everything else is just a star around the outside. You're going to be able to update it really quickly. Now, how much time is it going to take to make reality match that new diagram? Weeks? Months? I've been on at least one project where it was years. So it's actually okay to do this by hand. It's going to change very rarely. When it does change it, you can change it very quickly. The percentage amount of effort and time required to keep the diagram up to date in comparison to the amount of work required to make your system match that is very small. So do it by hand. Write it on a whiteboard. Do it on a piece of paper. Do it frequently, because the more you do it, the more you're going to burn that information into your brain. And get your team to be able to do it, so that everyone on your team should be able to reproduce one of these diagrams. What about the next level down, the containers view? Well, here we can start to interrogate the code to try and pull out some of the structural information. If you've got a project inside Visual Studio, you're looking at projects inside of a solution, and you can see the technology stacks that those things are based off of. You can see which ones are desktop applications and which ones are web applications. So maybe you can start to pull out some of that detail and do some of those things automatically. But you're still not going to be able to show how those things are connected to external systems, or you're not going to be able to show very easily how those things are connected to each other either. And the technology choices required for the intercommunication is probably something you're going to have to add in manually. Skipping the components for a minute, how frequently do you think a class view changes? I would hazard a guess that every single check-in has a chance that it's going to break one of these class views. Even at the higher level, at the components view, if you generate one and look at it, depending on the speed of your team and your continuous integration software, there's a chance it's wrong within about 15 minutes. Don't do these by hand. So where you've got a context view and a containers view, you're only going to have one. You're going to be able to print one side on a piece of A3 paper and flip it over and print the other one on the other side. You can carry that around as a single sheet. And you've already gone a significant way towards documenting your software architecture. The components view, you're going to end up with at least one per container. And we already saw that in any sufficiently complex container, that's probably not good enough. So you're going to end up with a lot more of them. Don't do them by hand, because they're going to very quickly and easily go out of date. And then it's just a waste of time. You may as well just not bother. So if we're talking about doing things manually versus automatically, what do I mean? Well, after talking about C4 for a number of different years, Simon created a startup called Structurizr. Structurizr is two main things. Firstly, it's this website, structurizr.com. And if you go there, you can sign up for an account and you can start to create models in C4. And then you can create views. So you can create a context view and a containers view and different component views. It doesn't currently go down to class views, but that's usually good enough. But the other thing that it is it's a client library. And it's implemented in Java and in C#. Both versions are up on GitHub. And the C# version is actually available via NuGet. And you can install this package, and then you can construct a workspace, define all the users and software systems that make up your broad context and how those things interact. You can construct a view, a context view, and then push it up to the website. And that's literally all the code you need to run. And when you go to the website, you'll see this, which is pretty similar to the context view that I showed you for service control at the beginning. Okay, well now that we've got that, we can move in and we can go down to the next level. We can take our software system and we can start to decompose it into its containers, again using the same kind of very simple API. We can construct a container view and then push it up to the website. And when we go there, we get a containers view. Now this is awesome for 3 reasons. Firstly, when you check this in with your code, you can include it as part of your continuous integration, which means every single build that you do can produce architecture diagrams for you. And they can be pushed up to the cloud. And then if you actually build these diagrams in Structurizr, you can embed them into documentation. So you can actually create links to the URLs, and it's just going to feed up the most up-to-date documentation every time you call it. The second reason it's really cool is because it's going into service control, you can use your service control tools to look at the history of your architecture over time. You can start to diff and blame your architecture, find out who did what, when, and why. And the third reason this is really cool is the unofficial reason, which is that we all hate Visio, and Visual Studio is much cooler than that. So now we're actually getting to write code. All right, what about if we want to go any further than that? We want to go down below the containers. So remember I said the context view and the containers view are both something that you're probably going to want to do by hand. So even if you're writing code to do it, you're still maintaining those things by hand. If you want to go further than that and decompose one of your containers into its subsequent components, Structurizr will do that too. You have a couple of options. First option is that you can do it by hand. Now, as I said, this is incredibly dangerous because it's really easy for these things to go out of date. And you can spend a lot of time looking at the wrong diagram and not really understanding what it is that you're looking at. So what would be really good is, because we're actually looking at code, what if we did some reflection over the compiled assembly and then called this API? So we can pull out the individual components and then call this API for each component that we find so that we can produce the collection of components. That's actually already built into Structurizr in a thing called a component finder. And you can configure the component finder with a number of different strategies to basically say, what are the rules that I've set up here? So if you implement iEvent publisher, then you're an event publisher. If you extend import enricher, so if you're using import enricher as your base class, then you're an import enricher. And when you call component finder find components, it's going to run through all of the code and it's going to pick out all of the things that match, and it's going to construct those component records for you, so you don't have to do it by hand. And again, if you've added this into your source control repository, and now you're doing it on every single build, you have up-to-date architecture documentation coming out on every single build. Now, at the modeling level, you want all the components you can possibly find in the system, and you want all of the connections you can possibly get. But when you're doing the views, those visualizations, remember, don't try and put everything in the same view. It's going to be very complicated. So you're going to have to be a bit more careful about how you pick out the individual views, the individual components to show on each view. So that's all I'm going to cover in terms of C4 and Structurizr. I've got some resources and things at the end if you want to have a look. But the last topic that I want to talk about is visualizing messaging systems. When I talk about messaging systems, in Service Bus, we have these things, these different processes that are going to be running on different machines scattered throughout your architecture. And in Service Bus terms, we call them endpoints. They're actually reasonably close to something like a container in C4. And what happens is when these endpoints want to communicate some information, they're going to package up that information into just a normal .NET class called a message. And they're going to hand that message off to some infrastructure to deliver it somewhere. Now, importantly, the code that's sending the message doesn't know where the message is going. So it just creates a message and it says, send this. It's a logical operation, saying that it wants something to happen, and the infrastructure takes care of ensuring that something on the other side will handle that message and do something for you. When the message gets to the other side, this endpoint could be down. Maybe you've taken it down for maintenance. Maybe that machine is down. Maybe even the communication pathway between these two things has gone away. You know, somebody in the network has unplugged something. But the infrastructure will make sure that this message arrives at the endpoint that needs to process it. And when it gets there, it's going to call some code, just some custom code. And part of that custom code could be anything. Maybe you're talking to a database, maybe you're talking to a file system, maybe you're processing an image or creating a PDF or sending an email or doing a credit card payment, whatever it is. But part of what you can do is then send another message. So you can have this stream of messages happening throughout the system. And because the endpoints aren't really aware of each other, they're all very loosely coupled. There's a special type of message which doesn't get sent, so it doesn't go to a specific destination. It's called an event. And events don't get sent, they get published. And rather than going to a single endpoint, a number of endpoints in your infrastructure, they can all subscribe to messages of that type. So if these two endpoints down the bottom are interested in order shipped events, when this endpoint at the top here publishes that event, it's going to get pushed down to both of those endpoints. Now again, this endpoint, the one doing the publish, isn't aware of the subscribers. It doesn't know who they are. And these subscribers, they're not aware of the publisher, so they don't know where that message is coming from. So applications built this way, systems built this way, they tend to be very flexible, very fluid, because it's really easy over time to add new endpoints that are publishing new messages and publishing new events and subscribing to existing events, and then you add still more endpoints, and they're subscribing to a subset of those events, and they're all publishing their own events. And what you get is a sort of emergent architecture, where over time you have this soup of events and endpoints, and the infrastructure is making sure that everything continues to work. But each of the endpoints is typically only part of one software system in your enterprise. So we might have one software system here and one software system here. And the fact that they're communicating via events means that those endpoints aren't actually aware of one another. So it can be very difficult to keep track of how those things are communicating over time. And sometimes the business will come to you because something has happened and they just don't know why. They don't know why that thing has happened in the first place. They have no idea. Now, it'd be good if you'd be able to answer those questions, right, straight off the bat. When the business comes to you with a question, it's awesome if you've already got the answer. So the first trick we're going to pull is we're going to create a central location called an audit log. And every time you get a message and process that message, you're going to stick a copy of it into that central audit log. And that means whenever the business comes to you and says, how did we get into this state? You can point at the audit log. The answer is in there. Has anybody ever tried to find a needle in an actual haystack? Because if you've been running one of these systems for a while, your audit log is going to have tens, hundreds, thousands, millions of records. And finding the ones that are relevant is going to be really difficult. The trick to finding a needle with in a haystack? Get a really big magnet, right? So how do we get a magnet on top of this data? We need to turn it from being just a data store into being a database, something that we can query, something that we can pull information out of on command. But in order to do that, we need some metadata associated with each message that's going in, so that we can use those to query and visualize what's happening. So the first piece of metadata we're going to add is a thing called conversation ID. And this is just a number that's going to uniquely identify a trail of messages through your system. It's really simple. When an endpoint wants to send or publish, send a message or publish an event, it's going to stick some kind of unique identifier on it. And normally this is a GUID. Here I've used an integer, but rest assured the identifier 17 is unique across all my slides. So normally you'd use a GUID, because then it's going to be unique across all of the endpoints in your system. The infrastructure is going to add this conversation ID, and then it's going to deliver the message to wherever it needs to go. And when it gets there, there might be new messages that are coming out. So as a result of processing ship order, we might be publishing an event saying order shipped. So the infrastructure is going to take the conversation ID that we have for the incoming message and copy it into the outgoing message. It's kind of sticky identifier that's going to travel through the system. And when the order shipped event gets handled at the other end, if that results in more messages, those messages will also have the conversation ID 17. This is really important because once you have an audit database filled with all these messages, if you find one that looks kind of interesting, or if the business comes to you with a question and you find one message that looks like it might be part of that, you can pull its conversation ID and query the database by conversation ID, and you can find all of the other messages that were related to that one sequence of events. So, the NDC Sydney 2016 Twitter leaderboard is built on top of a messaging system. It's running on top of in-service bus. We are collecting all of the messages that it's processing into a central database, in this case, service control. And so when I found a message that looked kind of interesting, I found its conversation ID and I queried it, and I got like a bag of other messages. So we got 7 messages. Now this has already helped immensely, right? Because we had thousands of records, and now we have 7. But we can still do a little bit better by capturing a little bit more information, a little bit more metadata. So we need 2 more to be able to produce a useful visualization. The first one is message identity. Pretty simple. Every message that goes out of an endpoint is going to get its own ID. When it gets to the other end, if there's new messages that come out of that, they're also going to get their own ID. But now we want to show that there's a relationship between these two things. So by querying conversation ID, we can pull both of these messages out. But now we've just got a bag of messages. We want to show a relationship between them. So when this order shipped event is going out, we're going to copy the message ID from here into a new metadata field onto the outgoing message called related to. Now, because we've done that for every message in the conversation, whenever we're looking at this bag of messages, we can figure out for each one which message caused it. Which means we can show a certain type of visualization called a message flow. And we can show that ship order led to order shipped happening. Back to the Twitter leaderboard example. These are the same messages again, but now I've added message ID and related to. So now we can use that information to arrange these into a message flow. And we can see that processing analyze tweet led to tweet analyze being processed 6 times. Why 6? Do you know what has a guess? No, it's not retweets. So the reason why there's 6, we can find by adding, again, a little bit more metadata to our audit log, and then we can update the diagram with that new piece of metadata. So in this case, what we're going to do is whenever an endpoint processes a message, it's going to receive a message, and it processes it to do something, it's going to take its name and stamp it into the metadata of the message. And then we can show that metadata on this diagram. There we go. So the Twitter leaderboard is running on an application called HashBus, which is where that name comes from. But here we can see this HashBus application processed analyzed tweet, and that led to this endpoint processing a tweet analyzed, this endpoint processing a tweet analyzed, this endpoint processing a tweet analyzed, and there's 6 different endpoints that are processing that one tweet analyzed event. And each one of them is a projector. We don't need to worry about what a projector is. We can talk about that in a minute. So this is cool, right? We've already managed to, just by querying the database, we can start to get a picture of what our system looks like under the covers. But where did this analyzed tweet come from? Well, it doesn't have a related to, so we know it wasn't caused by another message coming through the system. It was caused by something else. But it still had to be sent from somewhere. So just as we added processor metadata to each one of our messages, let's add sender as well. And when we do that, we can update the diagram to show where this message came from. Awesome. What other metadata can we add to this? Let's add some timing information. Let's add when messages were sent and when they were processed. Pretty simple. But now we're starting to get into this problem again where we've got too much detail happening in this diagram. This diagram isn't the right way of looking at this detail. When you're looking at timing information, what you want to see is a timeline of how things were of how things happened. And it's actually easy to do. We can do that with just the metadata that we've got here. So now that we have the conversation, we have a list of endpoints that are involved in that conversation, the ones that processed and sent messages. So we can pull out that information. We can draw them all as boxes at the top of our visualization. And then we can add in the concept of time. We're going to throw in some timelines. And here we're saying time is going to move forward as we move down the view. Now, because we had the information about when things were sent and what things were sent, and we know which message started the conversation, we can add it to the diagram. And we can show this endpoint sent a message here, and it was processed during this block of time. And then we know the sequence of events that followed from that because we have all that in our conversation. We can see which messages went out as a result of that message. And we can easily draw it onto this diagram. Now, what wasn't obvious from the previous visualization, but is probably, hopefully obvious now, is that this endpoint processed things a little bit later than all the rest. So if you had an issue in your production environment related to timing that you needed to diagnose, and you had all this metadata already in your audit database, you can just walk up to it and produce this visualization, and the answer jumps off the page at you. You can see it. Not only that, but it's starting to show the static relationships between these endpoints. Remember I said the endpoints aren't actually aware of each other. So this HashBus Twitter monitor, when it sends an analyzed tweet, it doesn't know where it's going. But the infrastructure is going to deliver it. And it's going to deliver it to this HashBus application. And then HashBus application is going to publish an event, but it doesn't know where that event goes. But here we can actually start to see where that event goes. We can see the static relationships that happen between the endpoints. So we can pivot the diagram again. We can show the endpoints, and we can show the messages that flow between them. But there's actually a problem with doing it this way. Does anybody know what it is? The problem is that we're not showing everything. The problem is, just like every project and every endpoint only has a part of the picture, each conversation only has a part of the picture as well. So if you're looking at this conversation, conversation 1, you're not even going to see endpoint B because it didn't send any messages and it didn't process any messages. And then if you pick another random conversation, conversation 2, now we see endpoint B light up, but we can't see endpoints A and C. And it's hard to know by looking at individual conversations whether or not you're seeing the whole picture, the whole enterprise, and how everything is connected. We can do a little bit better than this. So imagine this is just a subsection of your audit trail. We've got which message was being sent, what conversation it was a part of, what message it was related to, where it came from, who sent it, who got it, and what it was, and what type of message it was. Let's throw away the first 3 columns. We don't need those whatsoever. For this next type of visualization, we're going to just use who sent a message, who received a message, and what type of message it was. If we look at the first row, we can start to draw part of our diagram. So we know about endpoint A and endpoint C, and we know about ship order between them. If we look at the next row, we can add any new information we find to the diagram as we go. So now we already knew about endpoint C, but now we know about endpoint D and the order shipped event. If we keep going, once we've been through the entire audit trail, we can actually build up a reasonable picture of all of the endpoints that make up our system and all of the messages that flow between them. Now, if we do this back on the Twitter leaderboard example, something startling happens. A brand new endpoint appears. One that's rarely used. One where we'd have to be really lucky to hit one conversation in a million to find that one conversation that involves the catch-up endpoint. So it was something that we wouldn't have drawn by looking at individual conversations. We needed to find the right conversation. And this type of view is using all of the conversations in your database to build up something. Now this is a step above what we were doing with C4 with static analysis, because this isn't how we think the system is going to behave. This isn't how we've designed the system to behave. This isn't how we hope the system behaves. This is evidence of how the system has behaved. This is a snapshot of the behavior that has actually already taken place. This is not designing your system. This is visualizing your system. You're actually seeing what your system is doing under the covers. Which means every time you want to look at this view, you should generate it again from scratch. Because you may have new data, you may have new information that's been added. But it can take a while to generate, right? Because you've got hundreds of thousands of millions of rows of data. So that's problematic. But we can do one step better than that. Because the process we just looked at is a MapReduce function. By looking at all your audit data, we're going to map each entry into an edge between 2 endpoints. And then we can reduce that set of mapped documents down into a distinct set of edges between nodes. And we can draw a diagram. Now, if you are putting stuff in an audit database and that audit database is capable of running a MapReduce function, you can keep this up to date in near real time. So you can have a consistent and always up-to-date view of all of the endpoints in your system, no matter which software system they belong to, and how those things are communicating. How are we back here? I missed something. Yeah, MapReduce, cool. So one last thing I want to cover about this type of visualization, which is that it doesn't show you everything. It's only showing the pieces that are doing messaging. So it's only showing you endpoints that are sending messages and processing messages, and it's only showing linkages between endpoints where they're happening via messaging. But there are other things happening in the system as well. There are external software systems that we're interfacing with. And this is where the knowledge of C4 and the usage of C4 helps, because we can start to just add those things manually into the diagram. So here I can tell you the top 2 endpoints that make up the Twitter leaderboard. They both talk to Twitter. It's not really a big surprise. We get tweets from somewhere, right? If you tweet #NDC Sydney, we have to know about it. So this is how we know about it. Those 2 endpoints at the top there, they talk to Twitter. And then they both send analyzed tweet messages, and they go down to this HashBus application thing, which is going to do some processing and figure out, whether or not this message is interesting. It's going to publish a tweet analyzed event, which is going to go off to 6 different projectors down the bottom here. But that's not the end of the story. It's just the end of the messaging part of the story. Because each one of those projectors talks to a web-scale MongoDB instance. On top of that MongoDB instance, there's a web API. And then connecting to that web API, we have a number of different viewer applications, which are the little console windows that you see around the place that show the top 10 people in each projector. So you really need to take this messaging view and augment it. You need to add in some things manually. So, some final resources. If you're interested in C4, Structurizr, and the works of Simon Brown, I highly recommend that you follow Simon Brown on Twitter. Check out Simon's blog, codingthearchitecture.com, where he talks a lot about how to do this sort of stuff. And he talks about architecturally evident coding styles. So how you can write code in such a way that you can find those components and things. Check out Structurizr.com. You can find instructions on Structurizr.com for how to sign up and how to create your first model. You can also find out how to get your hands on the client libraries and get started with those. If you're interested in me and visualizing messaging systems and what we're doing in particular, you can follow me. I'm Wolfbite with a Y. If you buy me a beer, I'll explain where that comes from. You can email me directly, so I'm Minutillo@particular.net. We had a couple of blog posts about this topic on the particular blog, and I'm going to tweet out a few links about the individual blog posts that I think are relevant. So if you're interested, go and check out twitter.com/wolfbite, and you'll find that. And if you happen to be building on top of NService Bus today, or interested in building on NService Bus in the future, and you are interested in these types of visualizations, we actually have tooling that does it for you already. So that's a tool called Service Insight, and these screenshots down the bottom are from Service Insight. So we can actually already collect all of your messaging. The NService Bus infrastructure already adds all that metadata and things into it, and Service Insight already produces those visualizations for you. So my name's Mike Minutillo. I'm about 9 minutes early, but that's all I've got for you. Thank you very much. So we've probably got 5 minutes. Does anybody have any questions? Yeah.
Even if you're not using messaging systems,
Yep.
but more like say synchronous API calls, say via like browser or some sort of API event, backend and other things. Do you think that the model still works?
Absolutely. So
The conversation ID, the message ID.
yeah, so really what you need is some way of correlating that information. So you need to know who was on one end of the communication channel, who was on the other end, and what the nature of that communication channel was in between.
So it really doesn't depend on whether it's pops up kind of thing or it's all the synchronous way. It still should work. The model about keeping those components that you said.
Yeah, absolutely. But it's much easier to do with messaging systems because you're already just putting those messages in an audit database. So it's really just sideloading more information into a process you're already following. Anything else?
Have you hooked it up with some sort of a more like a BI kind of dashboard, like Power BI or anything like that? Like instead of visually showing different things?
No, I haven't. It'd be really interesting to do, actually. Because, yeah, we collect all the data and the API is open, so it'd be possible to push all that into something like Power BI. That would be cool.
For the component views, the ones that you want to generate dynamically, showing examples where it's like looking at the basic classes and base definitions. Do you know if it's possible to use attributes instead? So
Absolutely. So the example of the code that I actually showed there, that was actually not using the built-in component finder strategies. So when you set up the component finder, you can specify the kinds of strategy you want to use for finding components. But you can write your own strategies. So you can put in whatever you want. So if you'd rather use attributes, you can do that. There's also an example on the GitHub that's not part of the main package that's using Roslyn to pull it out of XML.comments. Anyone else? Awesome. Thank you very much. I'm going to be at the particular booth, which is upstairs for the rest of the conference. So if you do have any questions, any comments, or if you just want to come check out what we're doing, come along to the booth and we'll chat to you there. Thank you very much.